It is excellent to see you this morning. I hope everybody is doing well. It was a very good start to the day. Let's see what kind of success we had. The effort is absolutely there. Let's see what kind of success. Number one, what did you get for the length of the altitude? I've got student number 7 and student number 2. Student number 2?
24.
The correct answer is 24 meters. Very good. I got 2 people who got it right. We'll survey in a moment. Number 2, what's the area of the triangle? I've got student 13 and 16. Okay, so we have a disagreement. Student number 21, what did you get? Well, the correct answer is 159.6 square feet. So, let's start with number 1. Give me a thumbs up if you got it right. Lots of people got it right. Very good. Put your thumbs down. What about number 2? Give me a thumbs up if you got number 2 correct. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Put your thumbs down. So, everyone's got their colored pen ready. Let's see if we can learn from our mistakes or learn from something that maybe we didn't remember. Dayanara, if you can think back, what was the first thing that you did for number 2 in an attempt to get the area? Of what?
Tan 61 is equal to 24 over x.
You put tangent of 61 equals 24 over x. How'd you know to do that? What led you to believe that that would work? Okay. Anyone else do the same thing? You guys did the same thing? Anyone do anything different initially? So a couple of things to make sure we are clear on. That's a trig function and it can only be used if it's a right triangle. Anytime you have an angle given to you, you have a right triangle, and you're trying to find a side length, there's a decent chance that a trig function is going to come in handy. So she's absolutely right. This equation from the concept of tangent works beautifully. Probably other approaches, but that is the exact approach I took as well. A note about the new calculators that you are going to be using. I think the other ones were a little bit nicer when it came to tangent because it allowed you to kind of put tangent within other expressions. This one, you have to type in the number, push the tangent key, and then either leave that number in and use it or round it off to thousandths or 10,000ths or something and then use it later on and then round appropriately at the end. In this case, you were asked to round to the nearest tenth, so it had to be 159.6. Anyone have any questions? So we're at a dangerous point in the year, which is, the danger is that there's so much to know. So much to know. It's just flat out difficult to remember everything. It really, really is. So I sympathize with you. Unfortunately, moving forward, our goal is to be able to remember everything. So we're going to work hard to achieve that. This warm-up also served a second purpose. Second purpose is that trig functions and triangles are going to be used today for today's lesson. So are there any comments, questions, any observations from today's warm-up? Of course, you've already titled it Lesson 11.3, and we're going to be exploring the areas of regular polygons. Okay, let's pause here. Okay, we're back as a whole group. We're doing very well so far. I'm proud of you. Today we're going to explore the areas of regular polygons. And I've already given you a sheet to help you along with your notes. That's done on purpose because some of the figures we're going to be exploring are complex. And I gave that to you so you would actually write things on the picture rather than having us all to waste time, drawing a picture that I put up. So we can focus on the actual work, okay? So I expect you to be writing things. Staplers will stay out. If you want to staple the work in at the end, by all means. But you're going to be kind of going back forth from your notebook paper or graph paper to the pictures and back and forth, okay? So the process of finding areas of regular polygons is a little bit involved, and initially it's going to seem like a lot. But remember, we've been through this in the past where something seemed overwhelming initially, but once we understood and got through it, it wasn't nearly as challenging as we thought. And you're going to see that. There's also a lot of logic involved and just kind of thinking through things. So our objectives today are to be able to develop and apply the formula for finding the area of a regular polygon. We have some new terminology that we haven't seen before. We studied circles for quite a while, and we learned that a circle has a center, and so does a polygon. You can actually think of the center of a regular polygon as if it's the center of a circle that's going around the polygon, or circumscribed about it. So here's a major new word that you're going to hear a lot today moving forward, the apothem. And we're going to talk about what that is in a moment. And then the central angle of a regular polygon is very similar to the central angle of a circle. So there's a lot of connections going on here. Any questions so far before we go a little bit deeper with these different pieces? All right, so this is not to copy, this is to explore with me. So I have a diagram here. This one I did not give to you. The center of a regular polygon, it's just like the center of a circle. It's equidistant from each vertice. In fact, the line that connects the center of a polygon to the vertice is actually called a radius, just like for a circle. So it's equidistant, meaning that all of these distances are going to be the same. That's going to be the center of the polygon. The apothem. And this is going to be important moving forward. The apothem is the distance from the center to a side of the polygon. So there's an apothem that's drawn as a dotted line. We can draw other apothems. I can draw one like that. Did I do a good job of drawing it? So there's a detail about an apothem that has to be true. What would make an apothem accurate? Kamoy? Yeah, it's perpendicular. It has to be perpendicular. This goes way back to the beginning of the year when we talked about the word distance. It doesn't say perpendicular distance. It doesn't have to. Distance is always perpendicular. So when we talk about the distance from the center of the circle to a side, we are implying the perpendicular distance. So you don't have to say perpendicular, but you must know it. So the apothem is always going to be perpendicular to a side, and it's the distance from the center to a side. Now, central angle. This is a central angle right here. It is bounded by two radii, or the lines connecting the center to two vertices. That is a central angle, and when you have a regular polygon, all the central angles are going to be congruent. So that's going to be congruent to that, and so on. You can find the measure of a central angle very easily. It's logical. This is 360 degrees. We have 5 congruent angles. You can simply find the measure of one of them by using 360 divided by the number of sides. This is a pentagon. There are 5 sides. There are 5 central angles. So the number of central angles equals the number of sides. 360 degrees divided by 5 will give you the measure of the central angle. That's going to be very important moving forward. Any questions so far? So we're going to develop this formula a little bit, but here it is. The area of a regular polygon. It's written as a theorem, but we're going to focus mostly on the formula. Capital A, the area, is going to be half the apothem times the perimeter. I've written it two ways. N times S is just the way you find the perimeter. The number of sides times the length of a side is perimeter. So as I've gone through this lesson and as I've tried to learn myself, I have found that I've used this formula virtually every single time. Yes, we calculate the perimeter, and we just do it logically. Calculating perimeter is a simple task, a simple idea. So to find the area of any regular polygon, we need two pieces of information. We need the apothem, and we need the perimeter. The perimeter needs the number of sides and the length of a side. The number of sides is easy, you can just count them. So the key things that moving forward are going to be the apothem and the length of a side. Those are going to be the keys. So we're constantly going to be looking for these two pieces of information, the apothem and the length of a side. And if you think about it, it makes perfect sense. Because if you can see what this shape is now divided into, it's just divided into a bunch of triangles. And the formula for the area of a triangle is 1/2 the base times the height. This is the base. This is the height. 1/2 the base times the height. Once we find the area of this one triangle right here, we just take that and multiply it by how many triangles there are. 1, 2, 3, 4, 5, 6. Multiply that result times the number of sides, and you would get the area of the polygon. So it's not like this is some magical made-up formula. It actually is the formula for the area of a triangle, just times the number of triangles there are. Anyone have any questions about that? Good, so let's jump in. Today's lesson is going to start with, I wouldn't say the most challenging, but it's going to start with moderate. And then we're going to do some simpler ideas, and then we're going to move to some really challenging ideas. So if you look on the sheet that I gave you, the first picture, the upper left corner, applies to example 1A. So you can go ahead and make notes right on that diagram or around it. This is a nonagon. If you don't know what that is, count. Then you'll know what it is. It's inscribed in a circle, and so here's the first time where we can really see the connection between circle and polygon. And you can really see that this is a radius because it's a radius of this circle, L, and it's also a radius of the nonagon. So you can see that connection now very easily. Find the perimeter and the area. The perimeter is going to be the length of a side from here to here, this distance, kj, times the number of sides. But it's a nonagon, it's regular, so we know that it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 times this length will get us the perimeter. So we can call this length S. So 9 times S will get us the perimeter. The area is going to be half the apothem times the perimeter. So even though we're asked to find the perimeter and the area, we have to find the perimeter to get the area. So the pieces of information, the things that we are really tasked with doing is finding this, and then we put it all together. And we don't necessarily have to find them in that order. So we need to find A, and we need to find S. Any questions so far? So let's start with A. And I'm going to give you a minute of team talk to see if you can develop an idea, a way of finding A. I'll give you 2 minutes. 2 minutes on the clock. How could we find A? Well, I heard a lot of interesting discussion. I didn't really want to interfere at all for that couple of minutes. So what did we come up with? What did you and your team come up with? Sharik, we'll start with you and then John.
Well, since the whole circle, hold on, right now.
Sure?
Yeah.
Okay, well, why don't you just tell me something? Try not to think of it as an explanation. Just try to tell me a piece of information that you know.
So this I found the central angle to be 40 degrees.
Okay, so hold on. Tell me the name of the central angle.
Center angle L.
Well, you can't say angle L because
KLJ.
Okay, so angle KLJ is where you started. Okay? So the measure of angle KLJ, you say is what?
40 degrees.
How did you get that?
Because KLJ is like an angle sector, and it's like 1/9 of the whole shape.
Okay. How'd you get the 40?
You get the 40 because we divided 360 by 9.
Very good. So we do 360 divided by 9, and logically that will tell us that the central angle is 40 degrees. Very good. I'm going to come back to you in a second. Sharik, John, did you guys do that as well?
Yeah,
Okay, and then where'd you go after that?
well, I used sine to find the sine of k and add km, and then I multiplied it by 2 to get s.
Okay, well, I asked you to work on finding A. So you got S. That's fine, so I'm going to come back to you for that. So we're still trying to find A, but right now what we have is the measure of this angle here. It's 40 degrees. So what I'm asking is, where do we go from there? Kamoy, you guys also had a method, and then Stephanie, and then Nathaniel. Go.
I found the measure of angle, like the two angles of KL, and that one is 20 divided by.
Well, this is an M right here, so KLM you're talking about?
Yeah, that's 20.
Okay, so how'd you do that?
I spread it by 2 because that's a perpendicular base.
It's not, well, perpendicular bisector would cut this in half. How do you know it cuts that in half? Because,
It's the angle by the.
yeah, it's a perpendicular bisector and it's an angle bisector because we have an isosceles triangle. So now we know that this angle right here, right there, is 20 degrees. Beautifully done and a great explanation. And what'd you do with that, Kamoy?
I did cosine, so cosine is 20 is equal to a over 4.
Okay, so I didn't put in the 4 here, but I took this triangle and I just made it here and I just rotated it and brought it over here. And you said cosine?
Cosine is 20 is equal to a over 4.
Okay, so cosine of 20 equals A over 4. Adjacent over hypotenuse. Very good. That's an A, by the way, not a 9. Let's make that an A. And so this turns out to be a little bit easier with this new calculator because you could just type in 20, push the cosine button, and then multiply by 4, and you get A. So Kamoy, what did you get for the value of A?
A is equal to 3.76.
Yeah, approximately 3.76. So we got that. Beautiful. Kadir?
This is something like a bit different. It was like I found like the measure of angle K by like in like the 180 times n minus 2.
Okay.
And so like I got angle K like the whole angle to equal 140. So then like I divided that by 70 and I got L K J.
Okay, and you used a trig function from there? Okay, good. You could also use the triangle sum theorem. You can do a lot of different things, absolutely. Okay? Stephanie, did you guys take the same approach that Kamoy did? You guys used cosine? And you found 3.76? Okay, good. So I asked you guys to find A, and it seems like a lot of us did. Nathaniel, what about your team?
I was given pictures for it, but Peter kind of into it for that angles, how to do that. And so what I did was I took the entire, well, I took the sum of the triangles there, and I found out that it would be minus 40. I had the total to the part of this blue, and I found the angle of KS and LAS.
Very good. Excellent. Because once we have this 40, this is an isosceles triangle, we know that that angle is going to be congruent to that one, and so you can find those measures. Absolutely. Great approach. John?
I did it different. I found km like first, and then I did the Pythagorean function.
Okay. So, and you had already said that you found this distance from here to here, right? Good. Okay. So we can take a similar approach, and John, you said, what did you use to get that distance?
I used
Sine of 20. Okay. So we'll call this x just temporarily, and you said the sine of 20 equals x over 4. Is that correct? And so what did you get for that missing distance?
1.36.
You get approximately 1.36 or 1.37. I got 1.37, but doesn't matter. I'm sure it's Close. And then what did you do from there?
I used my dagger. I did 4 square and then I subtracted it by 1.36 squared and I got 3.76.
Very good. So you got it also. Excellent job. So we've got A now by a number of different methods, but we still need S. So I asked you to spend some time finding A, but now we need S. Any thoughts? I mean, we could do a team talk again, but it's staring right at you, so I didn't really feel the need. Go ahead, come on. That's right. Because what John illustrated right here is this distance from here to here, that's half of S. So if we multiply that by 2, we'll get S. Go ahead. Multiply it by 2. What do you get? You already got, if you're just sitting there, I'm assuming you already did it. Alexandra, you got it? What is it? So you get 2.74, and so now we've got S right there. So now we can put it all together. Go ahead, find the perimeter and the area. You can do it all yourself. Now it's just plug and chug. Plug it in and chug it out. Give me a thumbs up if you got it. 1, 2. Good. Put your thumbs down. Here's a different technique. If you're done, take your hand, spread your fingers as wide as you can, and put your hand on top of your paper like this, if you're done. Spread your fingers, put your hand down if you're done. Good. Excellent. Relax your hand. Stephanie R., what'd you get for the perimeter? 24.66. Matthew, do you agree?
Yeah.
You got the same exact?
No, I got 46.
You got 46. Okay, so we have a disagreement. So we've got 24.66 or 46. Exactly 46?
I was wrong. That was the area.
Oh, okay, so I'm confused. So we're on perimeter. Did you get 24.66?
Yeah.
Okay, Matthew, what'd you get for the area?
46.36.
So you propose 46.36. Agree or disagree? What do you think? Valerie, you agree? Yep. Anyone have any issues, any concerns about how we arrived at these answers? Any concerns or questions? So I did this on purpose over here because I was trying to help you see that finding the area of a regular polygon is the same thing as finding the area of a triangle and just multiplying it by how many triangles there are. So whether you understand the formula or not, doesn't really matter. You can just find the area of one triangle and multiply it by how many triangles there are. So even if you forget the formula or you don't understand it, find the area of one triangle, multiply it by 9. Any questions about that? Good. Part B. Find the second picture, and we're going to find the perimeter and area of the decagon. But first I'm going to give you 2 minutes of team talk. There is no center. I would like you to spend 2 minutes developing a method for finding the center of this decagon. And then go ahead and do it. You should have rulers at your desks already if you need them. Go. Find me the center. Look at this one. Find the center. The exact center, not the approximate center, not a guess at the center, the exact center. I'm not asking you to find me the perimeter area yet. We're not on that. We need the center.
Oh, I know.
All right. Give me a thumbs up if you feel confident you found the center of that polygon. Good. Kayla, how'd you do it? Good. Good. So if I draw from here to here, well, that doesn't find me the center, but it looks like it cuts the polygon in half. But if I now draw this one, whoa, look at that. There's the center. You have to understand that each one of these orange lines is a diameter. If I circumscribed a circle around this, circumscribe means it touches every vertex. This would be a diameter, and so would that. If you can draw two diameters in a circle, you can find the center of a circle. So we now know the center is right there. We also, I'm sorry, any comments or questions? And I saw a lot of you drew all of them, connected all the opposite vertices, and you were able to get all the different triangles. That was important too. I'm going to connect one last one right here. Any questions on how we found the circle? Found the center? So now look back at the diagram for part A. Would that method work for part A? A bunch of people said yes. Some people are now saying no. Ziamara, you're shaking your head. Why not? Yeah. Odd number of sides, that method won't work because we don't really have opposite vertices. We have a vertex and an opposite side, but then we would need to know the exact center of the opposite side. So just to demonstrate, I could draw from this vertex straight across, that would go through the center, but I would need to know that exact center right there of that side, and we don't. So that method won't work because if I go vertex to vertex, I end up with a chord, not a diameter. So, odd number of sides, that method won't work. Even number of sides, maybe it will. But regardless, that wasn't really the major goal. The major goal is to be able to find the perimeter and the area. So now we're back to the shape and we're trying to find the perimeter and the area. We now know that the center is right there. And so that's a key piece. You've also learned that to find the area of a regular polygon, one method is to get the perimeter. This situation was a little bit different. So that's already staring us in the face. What's the perimeter of this polygon? Sharif?
70.
What is it?
70.
How'd you get that?
Because one of the sides is 7, and this is a regular polygon, all the sides are congruent, and since it's 10 sides, it's 70.
That's right. So we had this side is 70. I'm sorry, this side is 7, and it's a 10-sided figure, a decagon. So we know that the perimeter is 70. So now we know that area is going to be half 70 times the apothem. So it's 35 times the apothem. We need the apothem. So we need this distance right here. Go ahead, take a minute and see if you can find the apothem. When you're done, let's use the open hand technique. When you're done, put your hand wide open on top of your paper, and that will tell me that you found the apothem. All I'm asking you to do is find the apothem. Okay, so that wasn't, we're not supposed to be done, but let's pause for a moment. What is it that you're doing right at this very moment? What are you trying to do, Stephanie? What are you trying? What angle? Good. Did you already find it, or you're just still trying to find it? Okay, what is it? How'd you do that? Beautiful. So that was a great starting point. We now know that the central angle is 36 degrees. Good. Anyone go beyond that? You're right, it doesn't, but I guess it is.
I split 7 in half.
Okay, so you split the 7 in half, so we would have this distance right here, and you got what? Okay, so that distance is 3.5. Beautiful. So we know that this is 36, and we know that that's 3.5. Awesome. Anyone have anything else to contribute? You got more? Go. And what is that? So now we know that this angle right here is 18 degrees, because if the whole angle is 36, Kamoy reminded us that this is an isosceles triangle. The altitude, or the apothem, is the altitude, It's going to be an angle bisector and a perpendicular bisector. Very good. So now what can we do? What can we do? Put it all together, Kayla. Go ahead. Beautiful. Very good. Tangent of 18 is going to equal 3.5 over A because we're looking for the apothem. Give me a thumbs up when you got the apothem. Got 1, 2 people got it already. That's good. 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 Put your thumbs down. Give you another moment. All right, John, what does it come out to?
10.77.
Comes out to approximately 10.77. Very good. So now we have everything we need. We've got the perimeter, we've got the apothem. Now we can go ahead and calculate the area. Go ahead. Find the area. Straight up mental and calculator work. Give me a thumbs up if you got it. 1, 2, 3. Good, good, good. A whole bunch of people. Extol, what'd you get? Dinar, what'd you get? What was it? 376 point what? 0.95. 0.95. I got 377. Anything close to that will be great. Any questions or concerns on how we were able to accomplish this? Good, so from this point forward, we're going to move a little bit faster. Anyone have any questions on parts A or B? Good. Checkpoint number 1, find me the perimeter and area of this regular polygon. And this distance right here is the apothem. That is a right angle right there. We've got 2 minutes on the clock. few people finishing up, so I'll give you another 30 seconds. All right, let's see how we did. Perimeter only. Perimeter, tell me. Student number 9 and student number 16. Perimeter.
I got 47.
Student 16. Perimeter is 46, approximately 46.6. Anything close to that, I'll be fine with. And the area, I got student 14 and 20. Student number 14. Student number 20. So we have a big disagreement. Student number 5, what'd you get? Okay, the area is 151, approximately 151.5. Anything close to 151.5, I will be fine with. So comparatively speaking, I felt like this checkpoint was easier than the first 2 questions that we did. What'd you do to start? What'd you do to start, Kadir?
Instead of the like Pythagorean theorem, and so it's like 6.5 squared times b squared equals 8 squared.
Times
Plus.
plus. And that got you that distance right there?
Yeah.
And what was that distance?
4.66.
Approximately 4.66.
And then I doubled that to get 9.33.
Very good. And that gave you the distance from here to here.
Yeah.
And you said it's 9.33 approximately. Okay.
And I just found the perimeter, which was 46.65, and I found the area.
Very good. From there, you've got everything you need. You already have the apothem. You can find the perimeter by just multiplying this times 5. Multiply and divide it by 2. So the variations in the answers came just from how you rounded or how you found the different pieces of information. John?
I use sine.
Good. So you found the measure of this angle right here, and then you use sine to get that? Beautiful. Anyone do anything different? Great job. Anyone have any questions or concerns? Kalasia, when I called on you, you said something different for the area? Do you know where you went wrong? What was it? Okay, good. Do you see why you have to do that at this point? Very good. Excellent job. So was your answer half of the area? Oh, for the perimeter, and then that messed you up. Okay, I see. Very good. Thank you for sharing that. I appreciate that. All right. Next example, next checkpoint. You're not going to do any writing on your notebook paper. All the writing is going to go on the small sheet that I gave you, and we're going to go quickly. The goal of the next example and checkpoint is to make sure that you don't overthink. We're a group of very, very bright young people. Sometimes we make things that are easy hard, and we're going to make sure we don't do that. So, you might be asked to just find an angle. ABCDE is a regular pentagon inscribed in circle F. Find each angle. So you can just go ahead and you'll fill in right on your little slip right there. But what's the measure of angle AFB? Well, there's 5 angles, 360 degrees. Do the math. What do you get? Sheree?
72 degrees.
You get 72 degrees. What's the measure of angle AFG? Mental math. Nathaniel? Okay, well, I know I woke you from a distant slumber, but try to come back with us. Valerie? Yeah, we're just taking this angle and cutting it in half. It's 36 degrees. So I didn't mean to put you on the spot, Nathaniel, but make sure you're with us. And then what about the measure of angle GAF? Stephen,
54 degrees.
how'd you get that?
I subtracted 72 from the 180 and divided it by 2.
You subtracted 72 from 180 and divided that result by 2. Very good. So what did it come out to? 54 degrees. There was another way to do it, but that's great. So anyone have any questions on how to find an angle? Just simply find an angle. It's all based on central angle and the fact that this is a regular pentagon. Any questions? Good. Checkpoint number 2. Find me these two measures using the diagram that's on your paper. We're talking about a 1-minute activity. You can just write your answers right on your paper. You can just write it right into the diagram. What'd you get for the measure of angle TWX? TWX. I got student 8 and student 18. Student number 8. Student number 18. So it comes out to 15 degrees. Nicely done. What about the measure of angle TWK? I got students 7 and 13. 120 degrees. Nicely done. Anyone have any concerns, questions, issues, any observations? Anything at all? Well, that is excellent work. No questions about anything we've done so far today? That leads us to our team challenge. So, you see the last picture. You have all the resources you need. You have a ruler, you have a calculator, I gave you the diagram. Your job is to find me the area of one regular triangle. Each of those gray triangles is a regular triangle. So I would like the area of one of those. Find me the area of one regular hexagon. I'm talking about the white hexagons in the picture. And then I'd like what percent of the tiling is shaded. This is supposed to be a tiling from like a floor. So what percent is shaded? So you've got 3 questions, but I'll tell you that question A is the one that takes the time. The other ones come from question A. So you got 15 minutes on the clock. 15-minute team challenge. I expect great effort, hard work, communication, thought, creativity, and of course, if you need any help or guidance, just ask. I wish you luck. Yes?
Actually,
Well, you have the picture in front of you, so you can work with that.
like, what is that? And I was like, oh, the pop is, I got things.
A little bit different than mine, but I'm probably just method. No, I take it back. B is
I
good.
found,
Nicely done. Please don't reveal your answer to anybody. You
I
can
didn't use the process.
help people, but please don't give them the answer.
Yeah, it's 10.
Okay. So, we're going to come back as a whole group for just a quick moment. First of all, I'm incredibly impressed with this group. You guys did really, really well. There are 2 people in the room right now who figured it out, or at least figured out at least A, and maybe beyond that. Nobody in the other geometry class figured out anything, so you guys should be just simply proud of that fact. You guys did a really good job of communicating. A lot of your teams kind of sharing your thoughts and your ideas and what you're going to try and, well, what worked out and what didn't. And I really appreciate that. Was really good. So I'm not going to reveal the answer because you're going to see this again. And I want to allow for my students who have been working hard for 15 minutes to achieve that triumph of figuring it out. Because I promise you that on some level it will feel good. And I don't want to rob you of that. So my students who did figure it out, please do not share the answer with anybody. You can help. Try to keep it to simple guidance, but please do not reveal the answer. Okay? So I'm not trying to make anybody feel like a letdown or anything. Keep working the problem. Okay? So, let me get you your homework. Your homework is on page 729. Numbers 10 through 16, 19 through 25, and 27 through 30 you see in bold. That's where your extra effort is going to be. If you are finding that you are getting tired, because I see a lot of tired faces, then do the ones in bold first and work your way backwards. I put do the at-home tutor 11.4. That is incorrect. You're going to do the at-home tutor for 11.5, and these are not the right pages. You're going to have to find the correct pages for 11.5. So I decided to skip over 11.4 at the last minute.